What is up, you pussy ass pussy? My name is Flynn Wilson, and this is the Flynn Wilson podcast, and we are doing some studying today. Today is the 6th of October, no time to fuck around. I can't even talk to you guys. We're just gonna go straight into the studying. Last time this podcast didn't record, what I said last time was, actually, fuck it, I'll talk for a minute. I crashed my mum's car yesterday, the day before that. I crashed my mum's car, slight crash, fucking turned into some guy's tow bar. The other guy's car was completely fine. My car, a little bit fucked. That's probably going to cost me $500. I got laid off from my job as well. I got fired. Took a bit of an L that day. Not gonna lie to you guys. But I hit 140 on the deadlift, which I was pretty stoked with. I gave it 4 fucking shots. Failed the first 3 times because my forearms were giving out, and then got it on the 4th time. And that's alright. That is alright. And that dog just came and just licked me and then just pissed off. Because she doesn't understand that I'm talking to my computer and that I'm not talking to her. She gets a little bit confused about that. Like when I'm shouting at shit, I'm shouting at random shit. She doesn't understand that I'm not shouting at her. So she gets scared and she comes up to me. She wants me to pet her. Let's get straight into the work though. Equilibrium constant. Equilibrium constant, Kc. When you study level 2 chemistry, you learn that Kc can be calculated for any homogeneous equilibrium system at a particular temperature. Here's how you would write the concentration of products multiplied together over concentration of reactants multiplied together. Hey yo. Oh, what the? EEK, we calculate is spelled with a fucking K. Why not just EEC, you fucks? Because sounds better as eek. Yeah. Ice. Fucking notification.
Kia ora. Let's look at how we can use the EEK method to do solubility product calculations. So what is this EEK method? E for equation. So write the balanced equation first. That means you're going to make less mistakes when you write the expression, which is the KS is equal to, and you write the expression, and then you do the calculation. And always double check the calculation. And it's helpful to know that the EEK is in alphabetical order of equation, expression, calculation, so that it's easy to remember the order. Now, there are 4 types of calculations you need to know for the 91392 standard. We're just going to look at the first one in this video, but there will be more videos for the others. So, calculating the solubility product, or the KS value. So if you're given a solubility, and that's always given a unit of moles per liter, you can calculate the solubility product. And notice the sentence where it says in pure water. So the only source of the calcium and fluoride ions is from the calcium fluoride solid that you add to the water to dissolve it. So using the EEK method, first the equation. Notice that you've got 2 fluorides for every 1 calcium fluoride. Then the expression, and because you've got 2 fluorides, you have to square the fluorides. Now, if my solubility of calcium fluoride is 2.31 times 10 to the minus 4, it means the solubility of my calcium ions is the same, because 1 calcium fluoride gives 1 calcium, but the fluoride is double the amount. So when I substitute into the equation, then I've doubled it here because I have to double it. But so when I substitute into the expression, I have to square it as well. So my fluoride is both doubled and squared. And then we do the calculation. Notice I've done it very stepwise. So the more steps you put in, the less likely you're going to make a mistake until you get a final answer. And notice that we don't give a unit.
Fuck a unit.
There is a shortcut method. Now, you do need to
what the
know
fuck?
the type
Alright.
of salt for this method. So is it an AB salt, AB2 salt, or A2B salt? So very quickly, if I have an AB2 salt, then the solubility of the AB2
Oh,
is
this is using algebra.
S, which is the same for the A2 plus,
2S
but
squared.
it's 2S for the B minus because I've got
Yeah,
two
yeah.
B's.
4S
So write out the
squared,
equation
4S
and you can
cubed.
see that. And you'll notice that the Ks, my solubility
Divide
product,
both
is the
sides by
same
4
as
and find the
4S
third root,
cubed,
and then you've got
which is the
S,
same
just
for an
A, and then
A2B
times by
salt.
2.
So you'll see
You've
it's the
got that,
same.
motherfucker.
For an AB salt, it's a lot simpler. It's S times S, and so it's simply S squared. But please note this is only for pure substances dissolved in pure water.
Okay.
So it's always from a single source and not two different sources. And there's my little shortcut. You will be given those shortcut values in the exam.
What the
So
fuck?
here's an
Just
example
algebra.
of my calcium fluoride. If I use the shortcut method, I still have to work out that S is 2.31 times 10 to the minus 4 from the given question. And now I just substitute it into the 4S cubed. Please note that you don't cube the 4 because we've already cubed it, and you get the answer. Let's do another example. Barium carbonate. You are given the solubility. Calculate the solubility product. Remember, first equation, make sure it's balanced. Then the expression, and you should have no problems if you've written the equation correctly. Now,
Fucking easy. Calculate a cube root using a calculator. Shut the fuck up.
Kia ora. Let's use the EEC method for calculating solubility in this.
Awesome, I'll be
Okay,
able to
so remember the
finish
EEC
this
method,
lesson. I'll
equation,
finish 3
expression,
perfectly, go over
then
flavor
the
techniques,
calculation.
then
So
do
this is
waves,
to
and
make
then
sure that you
end
minimize
this podcast and do some
any careless errors. So hopefully
do
your
some drop
answer will
shipping
be
shit.
correct at the end. And remember also, you've got 4 different types of calculations you need to know. We've done the solubility product in the previous video. In this video, we're going to look at calculating the solubility, which means you've got to calculate the concentration of a substance. So you have a unit, and usually Ks is given, but we'll do an example where one is not given. So here is an example of silver chromate, where we're asking for its solubility in pure water. So we can use the shortcut method simply because the source of all my silver ions and all my chromate ions is from my silver chromate. So first the equation, then the expression, and remember my silver chromate forms 2 silver ions and 1 chromate because it splits over here. And so my expression, my silver ions are raised to the power of 2. And so if my solubility for silver chromate is S, this would have to be 2S and the chromate S, because 1 forms 2 and 1 chromate. So now I can substitute 2S and S, and I'll land up for the 4S cubed is equal to the Ks value of what's given over there. So I suggest you always divide by the 4 first. So to get rid of the 4 on this side, divide both sides by 4. And so you should get about a quarter of that, of 9.1 is around about 2.2. And now I take the cube root and I get an answer of 1.32 times 10 to the minus 4. Don't forget 3 significant figures and the unit. Also check, is your answer sensible? So if I take a cube root of 12, it should be 4, because it's 12 divided by 3 is 4. So it looks like a sensible answer. Here's another example with lead chloride. And again, this isn't pure water. So we can use shortcut methods because all my lead ions and all my chloride ions come from the lead chloride. So again, equation, expression. This is an AB2 salt, so we've got 2 chlorides for every 1 lead, for every 1 lead chloride. And so we can substitute in for S and 2S squared, so it becomes 4S cubed. Again, I divide by 4 first, get the cube root, and I have an answer of 0.0162 moles per litre. But we've got to make sure we answer all parts of the question, so we have to state what the solubility of lead chloride is, because that's what they've asked for. Don't just leave it as S. Write the solubility is. And we have to give the concentrations. Remember, square brackets means concentration of. So the concentration of the lead ions, and it's the same for every one of those. I get 1 lead ion, but 2 chlorides. So my concentration of chloride is double the concentration of the lead. And don't forget the unit and the 3 significant figures. So finally, this last problem is where we've got silver chromate again. And if we look at it, we've got to calculate the solubility. So we say, write equation, expression, and we want to now substitute, but we don't have a Ks. It's not given.
What the fuck? An experiment in a saturated solution was made by dissolving 1.445 times 10 to the power of negative 3 grams of Ag2Cr04. What the fuck's that? Silver chromate, I don't know. And water, and making it up to a volume of 15 milliliters. The molar mass of Ag2Cr04 equals 332 grams per mole. Okay, so you go N equals M over M, find out the concentration of that. And that's all you do, what the fuck? Yeah, you've got the concentration of that, and then you can find out the fucking Ks.
We have to look and see what are we given, and we say, well, a certain mass has been dissolved in 50 mils to make just a saturated solution. So that is going to tell us how much can dissolve. So we need to use our small n is equal to small m over big M. So here are our values, and remember our milliliters we have to change to liters, because our concentration is in moles per litre, so not moles per milliliter. So I now substitute small m, the mass, over the molar mass. Our grams cancel out, giving me a unit of moles for N, which is what we'd expect. And now I take that mole and I substitute it as the N over V. My V, remember, is 50.0 times 10 to the minus 3. Always use at least 3 significant figures during the working, and your final answer must be to 3 significant figures. So that is my concentration of silver chromate. So carrying on, because the question asked for the solubility as well as the silver and chromate ion concentrations. So if my solubility is that for the silver chromate, then it must be double that for the silver ions, and the same silver chromate and chromate is the same because it's a 1:1 ratio. Then finally here, it has also asked, by the way, is your answer sensible? Always just check that, and significant figures.
That makes sense, Sammy.
So they've just asked now to calculate the Ks, and so it's what we did in the previous video, where we write the expression, and we can do it in 2 ways. We can use, because my silver and chromate ions only come from silver chromate and nowhere else, I can use this shortcut of 4s cubed. And so I can say, right, my solubility is that much, 8.67 times 10 to the minus 5, cube it, multiply it by 4, and I get that answer. Or I could and again, it's no unit, I could just simply take that expression and then substitute my concentration. So for silver, I take my 1.73 times 10 to the minus 4 squared, multiplied by the concentration of chromate, and I get a very similar answer. It's slightly different because it has a bit of rounding off in here that has affected my final results. And this last slide is just looking at the difference between solubility and solubility product. Just make sure you're very clear when you answer a question, are they asking for you to calculate solubility product or solubility? So, kia ora.
So, kia ora. Cool. Solubility and solubility product, there is a difference. Cool. Alright, let's answer my questions I wrote. What's KS? I'll explain it to you. This is called the Feynman technique, where you explain something simply. And I do it immediately after doing a lesson for about 5 minutes. Probably go over because I've only got 2.5 minutes. What's Kc? Kc is the equilibrium constant. And it shows us whether the reaction is making more product or making more reactants. If Kc is above 1, then more products are being made. But if it's below 1, then more reactants are being made. You start off the reaction with only reactants and you start to produce products. And like that video we saw before with the water in the beakers, that was a good explanation. That was a good fucking video. As the reactants become products, the products will soon become reactants until you get to the point where the rate, the same amount of reactants are there and the same amount of products are there, because the rate at which they're changing from reactants to product and products to reactant are now equal. The forward and reverse reaction are equal. What does Kc show? What I just said. What's Ks? Ks is the solubility product, and it's really similar to Kc. It's like the equilibrium constant of things that are dissolving in water. So if it's really high, then it dissolves readily into water. It's only slightly saturated, or if it's I don't know if it's infinite, then it's not, or if it's really high, then it's just fully dissolved in the water. I guess Kc doesn't exist if it fully dissolves in the water, does it? Because there's no equilibrium happening. But if Kc is really high, then it is slightly soluble in water, and if it's really low, then it's sparingly soluble. And I'm pretty sure it was saying before that for to use Ks, it has to be sparingly soluble for some reason, because the concentration has to be below 0.01 moles per liter. I don't know. Didn't really go into that. What's stoichiometry? Stoichiometry is the amount of moles. In a substance in a reaction, like AgCr can go to Ag plus Cr. If it's 2Cr, then there's two moles of that, right? AgCr2 goes to Ag plus 2Cr. Then there's 2 moles of Cr and only 1 of Ag. And it matters a lot because with stoichiometry, with the stoichiometry number, how many moles of substance are in a reaction, you often will raise numbers to that number, like raise the concentration to that number in Ks or Kc. So it's not a linear, it's not just 2 times, it's squared. It's like the the Pedro distribution, which is a fucking good thing to know about that Pedro distribution. It like reaffirms the fact that progress is made on the edge. Anyways, that's off topic. What factors affect Ks? Only temperature. Like I just said, only temperature affects Ks. Whereas, so the solubility product and solubility are very different because concentration, temperature, and something else can affect solubility. But on solubility product, only concentration will remain constant, and only temperature can affect that. That's cool though. Alright, time for a break, and now we're moving on to waves. So I do 4 Pomodoro, 4 Pomodoro cycles in one, and then a big break, where usually I have a break, eat something, and then I fuck off and do something else, because I've got other shit on other than studying. So I'm going to do drop shipping after these 4 cycles. But today the plan is, if I have a look at to do today, so the plan is I've already done 3 cycles, so 3 25-minute cycles, so that's like a bit less than an hour and a half. I'm doing 1 cycle skimming. I skimmed through chemistry and wave lessons. I skimmed through what I'm going to do today. Watched the video on Ks as well, solubility product, because I saw that was important. Kind of get like a basic understanding of the shit that I'm doing before I do the actual lesson. And then I go into the lesson, do 2 lessons on chemistry, which I just finished, and 1 on waves, which I'll do after this. End the podcast. Have a morning tea break. Yeah, I'll probably have an early morning tea then, where I have some noodles and a Sammy. That'll probably be from 10, so I'll actually edit this because I kind of fucked up the timing on this. 10 to 10:30 morning tea break. So 10:30 to, this works way better though. 12:30. 12:30 to 1:30. Does it though? I have way less time. 1:30 to 3. Yeah, I'm actually doing less studying, but hey, it is what it is. Study 2 cycles on. This is way different. I think the plan actually here is going to be just a 50-minute studying chunk here. I'll do 2 chunks, but do a 50-minute study chunk here. Maybe even more. Maybe even a bit less. Take me to like 9:30 to maybe like 10 past 10, maybe 40 minutes of studying. That's the last chunk, and then only do 2 chunks. Love when my face never fucking met. Anyway, I'll take a shit. We'll be back. One of my TikToks has 9,000 views, which is alright. Oh, the camera isn't working. Fuck. Anyways, one of my TikToks got 9,000 views. The doggo lead one. It's still like the quality is. I'm just not worrying about it. It looks alright. It looks alright now. I've kind of found which I've kind of seen which like video clips work best and which work worse. It doesn't like anything that's like gravel or sand or anything does not work well with that at all. Works well with green colors, so I'm getting like greenery and shit. If you're just focusing on one thing as well, that works a lot better.
Well, let me just show you. There's a water bottle Kensington drags all in bulk so you don't have to carry around all that stuff in a backpack, and it makes walking it up.
If you're looking to get in shape in the comfort of your own home,
All of this gym shit pops the fuck off.
guess what? I have was.
Okay. That's my break over, Grover. Let's do some waves. The fuck was I gonna say? Oh yeah, I gotta email my teacher real quick as well. Dude, none of my work, I've got like 3 things that just haven't been marked. I don't know what's going on. I'm guessing that my teacher's marking mock exams right now. Maybe she's not even gonna mark TAs. Because like we've passed our fucking mock exams. Oh shit, it's the fucking holidays. It's the fucking holidays, isn't it? My bad. Oh fuck. Am I gonna be able to... Fucking holidays. I forgot that holidays were a thing. I always do that. Are they marking our mock exams then? Where's the workbook? Is there a workbook for this? Just worksheets. Fuck is this work? What? There is a work. I don't want to do worksheets. Come on, man. Don't make me do this. Come on. Whatever. I'm still doing physics. Like you forgot. Fuck. Yeah, I got an immediate email saying I am on school holiday leave until Monday, 18th of October. Fuck's sakes. Diffraction gratings. Okay. What's the date? 8th. Oh wait, what is that? 6th of October 2021. I'm back. The camera's back. It's working. Look at my forearms. Look at my biceps. I'm the fucking man, and you're a bit of a pussy. Except I don't know you. I don't know you. Who the fuck are you? Is it me? Yeah, it probably is. Am I even here? Fuck knows. Who the fuck knows? But let's do some work. I still got Anki up. Oh, I do. Anki. A-level physics online. Whoa, it broke. Make sure you read any risk assessments before using specialist equipment.
Okay,
Frozen.
What we have here is the horrendous DVD Frozen. Now, what I can show is if you look at the DVD itself, there's only white light in this room, but what we're seeing is a load of rainbows which are formed on this.
Yo.
And this is what I'd really like to talk about now. Why it is that we can get this rainbow of colours from the top of a DVD or a CD. We can actually see something very similar by shining laser light, which I talked through in the last video, through something called a diffraction grating. And as I shine that light through the grating, it splits out. Now we get a huge amount of really bright maximas and plenty of minimas where there's no light coming through.
Yeah.
And this is a bit like the two-slit experiment, but not using 2 or 3 or 4, but hundreds and hundreds of slits. If we have some form of light source and we send that light through a diffraction grating, what we get are a series of bright and dark spots on a screen. And that's what I'd like to really look through at the moment. So perhaps we have our diffraction grating over here. We get a bright spot, which we're going to call a maxima. And then there's going to be certain minimum spots. And then we have another maximum spot over here, and here, and here, and so on. Now, the one in the middle, because it's often the brightest, is called the 0th order maxima. Then we have the first order, second order, and this is a good way of working out the wavelength of light. Order maxima, here, and so on. Now, the one in the middle, because it's often the brightest, is called the 0th order maxima. Then we have the 1st order, 2nd order, and this is a good way of working out the wavelength of light. And what we say is that d sine theta equals n lambda. Okay, and I'd like to talk through this equation now. Now, if we think about a line that joins the centre of the diffraction grating to the 0th order, and also a line that goes to the 1st order, the angle between the two is equal to theta. Now, we can measure this very well in the lab. Now, the good thing about using a diffraction grating to measure the wavelength of light over the two-slit experiment is that there's so many different gratings here, it lets a lot of light through. So that means it's very easy to see the bright fringes that we see over here. We can also look at the separation of the fringes. Now, on the slide here, there are 300 lines per millimetre, so D is equal to the distance between the slits. Okay, the lambda over here is the wavelength of the light, theta is this angle here, and n refers to the order of the maximum. So we might have n equals 1, n equals 2, or n equals 3, and so on. Now, if we set this up in the lab, we maybe want to find out or just confirm the wavelength of light. If you set this up so you've got a large enough distance, to measure the angle theta is fairly straightforward, because we've got a triangle here with a right angle. We can measure this distance, and we can measure that distance, and therefore we can calculate theta. We can maybe look at the distance from maybe the 0th to the 1st or 2nd order maxima, and then we can very easily work out the distance between the slits. If we know all of that, we can work out the wavelength of the light. So why is it that this frozen DVD, as horrible as it is, why does that leave a beautiful rainbow of light? But yet if I shine red light on it from the laser, it just there's no other colours showing. Well, the reason for that is this acts as a reflective diffraction grating. What there are thousands and thousands of very, very small lines, so many hundreds of lines per millimetre, and that acts in the same way as a diffraction grating that we saw where we just had the light going straight through. And it's the light that's reflected comes out in the different colours. So if we can think about having a rainbow from white light on this, what would happen if we shone white light through our diffraction grating? What we tend to find is there's a bit of a sort of rainbow towards the edge. When you shine white light through a diffraction grating, what we find is that the equation we used before, where d sine theta is equal to n lambda, is very important. Now, provided we look at this, the 1st order maximum.
Brilliant. Make a note on this. What does d sine? Why is it like on dark mode? I don't know.
to find is that, so if we find per other colour maxima,
Cool.
and then we can very easily work out the distance between the slits. If we know the first order maxima to begin with, and we think about using the same diffraction grating, we can say that sine theta is proportional to the wavelength. Now what that means is, the longer the wavelength of light, so perhaps we had red light,
Green light.
as opposed to something like blue light that has a shorter wavelength, we find that this one here, theta, is going to be bigger than if we have this one here. So the theta is a smaller value. What that means is, in the very centre, we have all of the colours of light passing straight through, and therefore we have a white spot in the middle. If we look at the first order maxima, what we find is that the blue light doesn't move a huge amount, but then the various colours of light, I can't show them all here, but I'll just colour a couple in. What we get is that the light spreads out with the blue and the purple nearest to the white light. And what we get on the other side is the opposite, because we've got the blue light not spreading out as much as the red. So that's what we get for the first order. We get the same thing again for the second order. Again, the angle theta is going to be bigger for the red light that has a longer wavelength. And what we see are these sort of various rainbows that split apart from that the very white light in the middle. So this is important. We can use a diffraction grating to split apart white light. We can then look at the different colours that make up that light. And this is absolutely key when we look at astronomy. If we look by looking at starlight through diffraction gratings, we can tell about the different colours of light that are in the light that we're analysing.
Cool. This shows a pattern of light on the screen from the laser shown through the diffraction grating with the vertical slits. The laser light is monochromatic, single coloured, so it contains only one wavelength. What the fuck? Okay.
One, go.
Hi, this is Jacob. I just wanted to follow up.
One, go. One, go.
Hi, this is Jacob. I just wanted to follow up on my post about light bulbs by showing some examples of what the different kinds of light bulbs look like.
Look at
in
this
the
fucking
diffraction
dude.
grating. So this is the diffraction grating that I mentioned in my post that my wife keeps beside her bed so that she can have a rainbow whenever she wants it. I'm going to hand it to her to put in front of the camera. So above me we
Let's
have
see his
an
wife.
incandescent light bulb. This is your typical light bulb, the tungsten filament, and it outputs a full spectrum of color. And so when you put the diffraction grating in front of it, this will show you that you can see a full rainbow: red, orange, yellow, green, blue. And it should go in that order because it goes from low. The diffraction grating splits light up from lowest energy to highest, going from, I assume, top to bottom. Is that right?
Well, the blue is at the top.
The blue is at the top. Okay, other way around. So that's what light from an incandescent light bulb looks like.
But up here, that was the right way.
Yeah. All right. So now I want to show you what light from a fluorescent light bulb looks like. It doesn't look the same. So we have a fluorescent light bulb here in our room, and so if you could put the grating up in front of the camera, you can see that you don't see a full spectrum. What you see is instead you see an image of this light bulb in the whole lamp, but you see three different colors. And that's because the phosphors, like I mentioned in the post, that they coat the inside the fluorescent lamp with, emit specific colors. So they actually have three different phosphors on the lamp. And so that's the red, green, and blue that you see.
Well, I don't know shit from that. Just that this guy seems like fucking very, very chill dude. Dude, fucking end this lesson. Fuck me. I'll do this last lesson, however long it takes me. It'll probably take me like 15 minutes maybe.
In today's video, we will demonstrate how to measure the wavelength of laser light, and we'll be doing it with a diffraction grating of known line density. Now, before we begin, you're going to need to know the diffraction formulas. I prefer the second formula because it's easier to measure lengths than angles.
Okay.
Now, I won't be deriving these formulas for you. That's for textbooks. But I will show you how to use them. Here's what the experiment looks like. I'm using smoke so you can better see the beam. The laser lands smack in the middle on the 50, but gets spread out 20 centimeters to the 70. Notice also that the laser starts 1 meter away from where it's going to be landing.
That's cool.
This place is typically called the screen. The places where the laser beam lands are labeled as 0, 1, -1, 2, -2, and so on. You'll also notice that different colors get different amounts of diffraction. Less diffraction for green and less diffraction for blue. In our experiment, we were using the first dot, number 1. And it was a distance, the first dot, of 20 centimeters from the central dot, number 0. The wavelength, we don't know, but we will calculate later. The length from the laser to the screen was 1 meter, and the distance is the distance between the lines of the diffraction grating, and we'll have to calculate that right now. The diffraction grating says that it has 300 lines per millimeter, but there's 1,000 millimeters in a meter. That works out to be 300,000 lines per meter. Thus, in 1 meter, there are 300,000 lines, or this is equal to 3.33 times 10 to the -6 meters per line spacing. That's D. Now that we know that the distance is 3.33 micrometers, we can plug it into the equation and figure out the wavelength.
millimeters.
And when we do, the wavelength turns out to be 666 nanometers.
Wait, no, it can't be. It's gotta be this.
Very close to the label on the laser, which says 650 nanometers plus or minus 10.
Alright. Well, this will be the last listen, isn't it? Or is it? Let's go next listen and see if it's TA. Yeah, it is. Oh, fuck yeah. Okay, let's finish this, then we'll be on the TA for waves. 12, 11, 10, 9. Oh, that's just about significant figures as well. What the fuck? Dope. Alright, I'm done waves. Fucking sick. Who the fuck was on there? What the fuck? Who else was on my dock? You fuck. Alright. What's a diffraction grating? A diffraction... Is my camera on? A diffraction grating is when there are more than two slits that light is being shone through that results in constructive and destructive interference. You'll see a maxima where there's a fucking bright as shit spot, and you'll see a minima where there's a fucking really dark spot. That's because the light goes through these more than two gratings. Usually it's a fuck ton, like before that guy was saying, 3,000 lines, 3,000 gratings per millimeter, so 300,000 diffraction slits per meter. Usually there's a fuck ton of them. The light goes through that, and it interferes with each other because light is weird. Light is weird. It's like a wave sometimes, and it's like fucking matter the other times. But this time it's waves. We're just going with the wave of light, whatever. They go out and they all interfere with each other. And some of them, if there's a crest on a crest, it's called constructive interference, where those light sources, because they're interfering with each other, make it even brighter. And that's where the minima is found, when there's constructive interference, where a fuck ton of these waves of light have come together and added on top of each other. The minima, where there's no light, they've done the opposite. The trough of one light has met the crest of the other, and they've essentially cancelled each other out. That's diffraction grating. D equals 1 over N. See, I didn't even fucking go into that. The distance... I honestly don't know. Distance equals 1 over N. What the fuck? I'm guessing N equals the order of the maxima. How is distance between slits equals 1 over N? Maybe that's an L over N. I don't know that one. Maxima and minima spots. Like I was saying before, a maxima is a point of constructive interference where all of these lights from these different gratings have combined to make a very bright spot. Minima is where the opposite has happened, where they've actually gone against each other. The trough is meeting a crest and basically cancelled each other out. So no light is shown. first and second order maxima. So the order of the maxima, right in the middle you're going to get the 0th order maxima. And that's where the most constructive interference has happened. It's the brightest spot you're going to see. Right in the middle. There's a fuck ton of gratings. Right in the middle is where the 0th order maxima is going to be. That's just how the constructive interference works. Right in the middle is going to be the best constructive interference, the brightest spot. The first is going to be slightly less bright. So there's going to be one bright spot, a large amount of black, another light spot. This is maxima, this is constructive interference, that's all destructive interference until the lights have again combined with constructive interference to make another bright spot. That's the first order maxima. It's going to be slightly less bright than the 0th order maxima. Because although constructive interference is occurring, there's 300,000 slits per meter. So there's still some that are going through destructive interference. So it's not going to be as bright as before. Kind of like how the dark spots are also going to be less dark. There's going to be slight smidgets of light. Is that right? No. Who knows? But anyways, the first line out from the middle line, that's first, then you go second, third, fourth, yada yada. And that's the order maximas. They are represented by n in the equation. In the equation that I'm about to explain here, d sine theta equals n lambda. So that's referring to diffraction grating, which we were just talking about before. D sine theta equals n lambda, where d is the distance between slits. Sine theta is the angle between the light being shone and the slit that you're measuring from. So here the light is, and this is the slit that you're focusing on. So it's this angle right here. That's theta, and the d sine theta equals n lambda equation. N equals the maxima, what maxima you're measuring from. So the third maxima, okay, so 0, 1, 2, 3, measuring from that one, there's 0, there's the light being shone, that's the angle, that's theta, and that's n, the maxima that we're measuring from. And lambda is the wavelength of light. You can use that equation to figure out any one of those factors. If you don't know the wavelength, you can substitute in all of the other numbers. So the distance between the slits, the angle between the light and the slit, the actual numbered maxima, the slit that we're measuring to, and yeah, you just sub those numbers in to find wavelength, or it can be any of those numbers. If you know wavelength but you don't know n, you substitute in all the other numbers. Algebra, n. The last thing, monochromatic. Monochromatic light is just light that is of one wavelength. So white light is not monochromatic. White light is a fuck ton of different wavelengths all combined. It's a spectra of light. But monochromatic can just be like solely fucking red. It's just made up of red light. It's not a combination of red light to blue light to make purple light or some shit. It's just fucking red light. And monochromatic light through a diffraction grating will just result in a fuck ton of bright spots of just that single light. Not like, because when white light is shone through there, it's fucking all splitting apart into a fucking rainbow. You know what I'm saying? This is cool beans though, huh? That's cool beans. I finished waves. We're onto the TA for waves. I have to figure out what I'm gonna do for. I guess I'll download those worksheets and do those worksheets for. So I'm doing SQ3. I just did S, skimmed over, Q question, done the lessons. I'm gonna do practice questions, then Anki cards for spaced repetition, and then skim over tomorrow's shit. But I gotta figure out how I'm gonna do the practice questions, because usually you do the workbook. But I'm not sure if there is a workbook for this equilibrium shit. Equilibrium principles or whatever. Maybe just a fuck ton of worksheets. So I'll probably just do those worksheets to lesson 3, which I got up to. Alright, this motherfucking podcast. Yesterday's podcast cut out. Fucking sucked. I talked about a lot of shit about how I crashed my mum's car. Took some hours. Got fired from my... Not really fired. I had a contract, a part-time contract. They know that they don't need work in the future. We've just gone through the busiest part of their season. And so my ass was basically first on the chopping block. Because I'm the only, like, part-time guy there. I'm not a full-time contract. So, it is what it is. It is what it is. I'll probably... It's October now. Exams are in November, December-ish. Maybe study, maybe get like... What's probably going to happen is I'll focus hard on the dropshipping shit, as well as the schooling shit, get excellence on all my tests, fucking easy peasy. Really focus on the dropshipping shit, building up all the stores, and then running some ads for some of them. And then after exams are done, sweet as, I can focus the same amount on dropshipping, and then the time that I was spending on exams, studying for exams, I can now focus on a job, get a job so that I can pay myself to do dropshipping as well as make some more money. Because obviously I lose money on dropshipping. I can't wait till December the 4th, which is my birthday, so I can get... I'm 18. Isn't that crazy? And I'll be able to get a credit card. Fuck yes, get some good cash flow going and build up some credit for myself. Cool, anyways, that's the podcast. Peace out, motherfuckers. Oh, that's awkward, I didn't even click it. Peace out, motherfuckers.